This video is about functions, function notation, and domain and range. To get started talking about functions, we need to understand some vocabulary. The first vocabulary item is domain. This is the collection of objects that are possible inputs for a function. That is the set of all inputs, or when we're talking mathematically, x values, for which the expression is defined as a real number. The range is going to be the set of all possible values that can be outputs. And for us, in mathematics, that means the y values. A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range. Let me give you an example. Let's say we have pet names. If we have a set of pet names and our cat is named Whiskers, our dog is named Buddy, our lizard is named Scales, and our horse is named Cinnamon, this would be a function because every pet has only one name. If, on the other hand, we had a cat named Whiskers, a dog named Buddy, a lizard named Scales, and a horse named Whiskers, this would still be a function because every pet has only one name. Let me give you a few examples of things that are not functions. We're going to take a look at toys from Santa. Let's look at the first one. In this particular instance, we have Johnny getting both a train and a baseball from Santa, Mary getting a doll, Susie getting an Easy Bake Oven, and Toby getting a baseball. In this particular case, this is not a function because here we have something in the domain, the first set, Johnny, getting two different things in the range, the toys, the train and the baseball. So this one is not a function because we have something in the first set corresponding to two different things in the second set. In our second example, this is also not a function for a different reason. In this case, we have Johnny getting the train, Marie getting the doll, and Toby getting the baseball. In this case, it's not a function because Susie does not correspond to any one of the toys. Remember that every element of the first set, the domain, has to correspond to the second set in the range, and in this case, Susie does not correspond to anything. So let's go back a little and continue here. A relation is a correspondence between two sets of objects. So in this particular case, we have a correspondence between two sets of objects, the domain and the range, and each member of the domain corresponds to at least one member of the range. In that situation, all three of these are relations and only one of them is not. In that case, this first one is a relation. Everything in the first set corresponds to something, at least one thing, in the second set. This is also a relation for the same reason. This one was not a function, this third one, but it is still a relation because they correspond to at least one thing. And this one here is not a relation because, again, everything in the first set has to correspond to at least one thing in the second set. Okay, now we were looking at things that were not mathematical. We're going to take a look at things now that are mathematical. One way, if we have a graph, that we can tell if we have a function or not is to use what's called the vertical line test. And it says if any vertical line crosses through the graph more than once, then it is not a function. So vertical lines go up and down. We're going to take a look here. For our first example, number 1, no matter where I draw a vertical line in this instance, it is only going to cross one place. So this is a function. This second example, number 2, you can see that it is possible to draw a vertical line and cross in more than one place. So this is not a function. For number 3, no matter where I draw my vertical line, it's only going to cross once. So this one is in fact a function. This fourth one is called a piecewise defined function, so don't let it bother you that it's different pieces. And notice, in most places, I'm only going to cross once. I might have a problem right here, but you'll notice that one of those endpoints is colored in and the other one is not. So it's really only touching right here at -2, 1. And similarly here, this vertical line is only crossing at 1, 5 because at the other point it's an open circle. So this actually is a function. And our last example, you can see fairly easily that if you draw a vertical line, you're able to cross twice, so this is not a function. Okay, so sometimes we see functions or relations as a graph, and sometimes we see these as a set of ordered pairs. So for our first example, A, we have a set of ordered pairs, and we want to talk about whether or not it is a function, and if either way, what's the domain and what's the range. So the domain, each one of these is an XY ordered pair. The domain is going to be our X values. So in this case, 9 and 2. Not necessary for me to list the 9 twice. And for the range, we're going to get -5, 5, and 4. And then if we want to decide if it is or is not a function, everything in that first set can only correspond to one thing in the second set, but you notice right away that 9 corresponds to both -5 and 5. So this one is not a function. Let's do that again. Our domain is going to be our X values, -2, 5, 0, and 4. Our range will be our Y values, 5, 7, 1, and -2. And in this case, every X value only corresponds to one Y value, so this is in fact a function. One more example. The domain here is -5, 0, and 6, and our range is 3. Every X value corresponds to only one Y value, so this is in fact a function. It doesn't matter that different X values go to the same Y value. It's the other way around, like part A, that we have difficulty with. When we talk about functions, we like to use the notation f of x. And the way we read that is f of x. And it's basically giving the function a name. So when we say f of 0, like we have here, what we're saying is, what is the value of the function f when we plug in a 0 for x. So in this particular case, we'd get 2 times 0 squared minus 0 plus 3, or 3. For f of negative 7, it would mean 2 times negative 7 squared minus a negative 7 plus 3, for a total of 108. Now this next example, you'll notice I have a variable in there, but the way that we do this is no different. It says take the function f, which we have right here, and plug in a 5a everywhere you see an x. So that will be 2 times 5a quantity squared minus 5a plus 3. Simplifying, we get 50a squared minus 5a plus 3. So pause your video for a moment and see if you can do parts D and E, and I will put the answers. So there you have it. We have 2a squared minus 15a plus 31. And for part E, 2a squared plus 3a plus 4. Here we have a different kind of function. Let's evaluate this function at f of 2, f of negative 3, and f of negative 3b. One thing that I like to do, I think of this as basically just directions telling me what to do. It's something minus 2 and something plus 3. And that something in this case happens to be a 2, so we get 0 over 5, or 0. In the same way, we have something minus 2 and something plus 3, and we're going to plug in a minus 3. So in this case, we get negative 5 over 0. We cannot divide by 0, so this one is undefined. And for our last one, something minus 2, something plus 3, our something is negative 3b, and we end up with minus 3b minus 2 and minus 3b plus 3. Can we do that looking at a graph? Well, a f of something, the function value, remember, is the y value. So when we're talking of f of negative 4, what we're saying is, where is the function if x is negative 4? So negative 4 is going to be here, and we notice that our function value is 2. F of 0 is the y value when x is 0. That is 0. The function value at 3, well, we're going to have to guesstimate here, about minus 1.8 approximately. And f of negative 5 appears to be 0. We could ask that question another way by saying, find x when the function value is 2. So we would look at where the function or the y value was 2. In that case, that is here and here, and we'll estimate that would be when x is negative 4 and when x is negative 1. This last example seems to have been cut off, so we will not do this last example, and we will move on to the next video where we will talk about more about domain.